Hey, quick note before we jump in today.
The Math is Figure Outable Challenge is open for registration, and we are diving into fractions, May 13th through the 15th.
If you want students to really understand fractions,
Instead of just memorizing steps, this is for you.
head to mathisfigureoutable.com/challenge to register now.
All right, on to the episode. Hey, fellow mathers, welcome to the podcast where math is figure outable. I'm Pam Harris, a former mimicker turned mather.
And I'm Kim Montague, a reasoner who now knows how to share her thinking with others. At Math is Figure Outable, we are on a mission to improve math teaching.
We know that algorithms are super cool achievements, but they're not good teaching tools because mimicking step-by-step procedures can actually trap students into using less sophisticated reasoning than the problems are intended to develop.
In this podcast, we help you teach mathing, building relationships with your students and grappling with mathematical relationships.
We invite you to join us to make math more figure-outable. Kim!
Yes, hi.
Oh my gosh, can I tell you about a recent experience that I just had? You and I've chatted about it a little bit, but I want to dive into it today. I have been thinking about this. I keep thinking about it. Okay, so I was recently had the wonderful opportunity to go to South Korea. Again, I've been there once before. This is now time 2. Both times I lost my suitcase. Really? What is that? It's fine. They ended up finding it in time both times, but anyway, wonderful. Chadwick International is an independent school there near Seoul, South Korea. And one of the things that they wanted me to do was some lab lessons. So we did some pre-conferencing about what was going to happen, do the math and make sure everybody's ready, then go in. I did pre-K through grade 8. Oh, look at me. See, I've been in South Korea. 8th grade. I'll probably do that because I'm thinking about South Korea. So each one of those, so 9 different lab lessons. And then we would do a post thing to kind of talk about what happened. And like I call it a post-mortem, sort of discuss all the things and everything. Okay, so let's just chat about one of them. In our last episode, we did the candy bar string where I said something like, if 3/10 of a candy bar weighs 12 ounces, what does 1/10 weigh, right?
Mm-hmm.
Okay, so I did that particular problem string with, I think it was grade 5. Pretty sure it was grade 5. And then the next day, I was supposed to go in. So one of the other things that I did were some full school PD sessions. And also, I went in and just observed some teachers and then kind of gave some feedback. In the 5th grade lesson, Sam had seen me do this problem string, and he was like, "Oh, hey, when you come into my room, you can watch me a little bit, but can you do that problem string with my students in his grade 4 classroom?" And I was like, "Are you kind of trying to get out of me watching you?" You know, we joked around a little bit. He's a great guy, wonderful, super guy. I really enjoyed watching him teach and interacting with him. So we joked around a little bit, and I was like, "Yeah, I'm happy to do that." Kind of funny. So I just said if 3/10 of the candy bar weighs 40 ounces. Sorry, no, that's the whole candy bar. I just gave it away. If you haven't watched that problem string or if you haven't listened to that episode last week, you might go check it out. The problem is if 3/10 of the candy bar weighs, help me, 12 ounces. Right. Okay. I'm trying to think here. I'm going to write that down. If 3/10 of the candy bar was 12 ounces. Well, when I was doing it with the 5th grade classroom, I hadn't thought about the fact that they don't deal in ounces. So half the kids are Korean nationals and half the kids are not. They're expats, embassy kids, teacher kids, people that work for high-tech companies over there. And so for sure the Korean nationals, but all the kids while they're living there, everything's in metric. And so I had thought about a lot of other cultural things and I missed that one. So I was a little chagrined standing in front of those kids. I'm like, okay, if 3/10 of a candy bar was 12, oh, crud. I'm like, kilograms? And I looked around. Kim, how are your kilograms? Do you have any sort of sense of?
Yeah.
So I pointed at a kid and I was like, hey, how much do you weigh? And then I thought, can I ask that? I mean, they're grade 5. Can you ask a grade 5? I said, never mind. Don't tell me how much you weigh. How much is like a normal, like average 5th grade normal? See, did I say that? I don't even know. Like an average 5th grade. I'm trying to get a feel for kilograms because I know I weigh a whole lot less kilograms than I do pounds. And I'm trying to think, what does a candy bar weigh? But Kim, funny enough, I'm thinking if 3/10 of a candy bar was 12 ounces, but I was thinking about the whole candy bar. And I'm thinking can a whole candy bar weigh 12 kilograms? That seems heavy to me. Does
Yeah.
that seem like a big candy bar?
Yeah.
The
Yeah.
kids are all laughing. They're like, whoa, that's a really big candy bar. But we were all thinking about the whole candy bar. Kim, if 3/10 of the candy bar weighs 12 kilograms, that means the whole candy bar weighs a whole lot more. Anyway, we're totally joking. It was great. The kids were so, I don't know, they were just in it. We're all trying to figure out kilograms and stuff. And like a dork, I said, I don't think it can weigh 12 grams. Well, it totally could. In fact, after that string, when I did the first time in the 5th grade, somebody handed me a granola bar. Are you ready? Oh, so again, go listen to the problem string. But if 3/10 weighs 12 ounces, the whole candy bar weighs 40 ounces. So they handed me a granola bar that, are you ready, weighed 40 grams.
Mm-hmm.
So it totally could have been 12 grams, and it would have like made sense that the whole candy bar could have weighed 40 grams. Anyway, all the things.
What did
So
you
by
end
that
up
point,
on?
say that in the class we did kilograms like a dork, because I just
Oh.
I know it's that moment in 5th grade. In 5th grade we did kilograms because
Yeah.
I was like, okay, everybody picture the biggest candy bar you can, and then we went with it from there.
Yeah.
And it still went great. But in between then they showed me the granola bar, and I'm doing the what do you call that when you put your hand to your forehead? You're like, ka-duh, you know, like
Yeah.
that thing. I'm like, duh, duh, duh. So when I did it with grade 4, I did do grams, and it
Okay.
worked. And we didn't even joke about it, which almost kind of lost some of its fun a little. But anyway, it was great. But so I go in. Wow, I'm telling the story crazy. I go in to Sam's classroom to do this lesson that he's kind of finagled me into doing. Way to go, Sam. And he's chatting with his kids. So of course I'm going to listen a little bit. You can already tell he has this great rapport with his students. And he says, as I walk in, he says, hey, am I right that you guys say the denominator first, but you also write it first? And I'm like doing that zoink thing where I'm like, say what? And he goes, you know, when you're talking in Korean, because half the kids are Korean nationals, so they're totally bilingual. In fact, it's amazing, Kim. I was talking to these pre-K kids who spoke no English in November, and they were full sentences. It was amazing. Anyway, so he says, am I right that, you know, when you guys say like a fraction, and he wrote 4/5 on the board. I said, so when you guys say a fraction like 4/5, you say the denominator, and then he said the word for denominator in Korean. He said, you say that first. And then you say the 4, the numerator, and he said it in Korean. And all those kids are like, yeah. Like, not even like, yeah. They're like, yeah. Like, of course, like normal. And I'm like, my jaw's on the floor. Now, I'd kind of heard a little bit that they said the numerator and the denominator in the order we don't, right? At 4/5, we say the 4 first, and then we say the 5. 4 for the fifths anyway, 4/5. And we often say 4/1/5. I kind of knew there was this thing where maybe they would say 5/4, but the way he explained it, it's kind of like we've cut the whole into 5, and I need 4 of them. It's kind of shorter than that, but that's the meaning that comes across in Korean.
Yeah.
That's interesting.
Yeah, it is.
Like, but what I hadn't realized is that not only do they say that I've cut the whole into 5 and I need 4 of them, or the 5's cut into whole. I have 5ths, but I need 4 of them. I have 5ths, need 4. It's kind of like that, shortened. Not only do they say it that way, Kim, they write it that way.
Yeah.
So on the board, he goes, so like for 3/4, you would say, I've got a thing cut into 4. He writes the 4. He draws the line. And then on top, on the numerator, he writes the 3. And I need 3 of them. And the kids are like, yeah. And I'm like, what? Okay, mind blown. If you could see my hands right now, I'm doing that thing above my head, you know, like boom. Kim, what are the ramifications for the fact that we say the numerator first? How do we think about fractions?
Yeah, I have so many questions, honestly. Can I ask my question first before we do that?
Yeah, totally.
So Sam was talking to his own students and asking them
Yeah.
how they do it. Did he mean like, did he not had he not talked to fractions with them yet? Has he like, how did he not, was he asking what they do in Korean, but that's not what he's teaching? I
Yes.
guess I'm okay.
Yeah,
Okay.
so the language of instruction in the whole school is English.
Ah,
So
okay.
they yeah,
Okay.
so everybody speaks English in the whole school, and the Korean
Interesting.
nationals have been going to that school since
I
pre-K.
see.
Like,
Okay.
once they start, they hang, they don't go in and
Okay.
out, but they also, this is just a Korean thing, they also go to these after-school academies. Some of them even
Yeah.
go before school,
Yeah.
and so they spend a lot of time in school. Some of the teachers were telling me last time I was there that the Korean government had to institute a new law a few years ago that those academies had to close by 10:30 PM. Like, it was
Wow.
illegal for kids to go longer. So these kids
Wow.
go to a lot of school.
Yeah.
And one of the things that I was doing, a little aside, at the school is they said, "Can you help us differentiate? Because we have these kids who go to these academies, have a lot of experience." The academies are kind of rote memory oriented. They're they are algorithm focused, but it still gives kids a lot of experiences, more than, say, the sort of average expats kids or the teacher kids who, are playing sports after school or, kind of doing regular kid things after school.
Right.
And so because of that, you might consider that their challenge to differentiate is even more of a challenge with their students because they have so much experience versus kids who have just less experience with a topic or, a kind of
Mhm.
math. Anyway, go
So,
ahead.
okay, yeah, so that clears it up for me because, he's the teacher, and so I wondered why he was asking. So, thank
What's
you
he
for
been
that.
doing?
No,
Yeah, yeah.
well, no, I mean, yeah, I figured it was that he was using instruction kind of more similar to what we would say. So we would
Ooh, ooh.
say
So can I say one more quick thing? So as I was doing the 5th grade, remember I did that the day before, the 5th grade lesson, the kids every once in a while, when they were gonna say 3/4, they would say 4/3. I mean 3/4. Or when they were gonna say 4/5, they would say 5/4. I mean 4/5. And they would kinda catch themselves quick enough that I didn't, I knew this kind of thing about how they might say it backwards, and so it didn't bother me, and we just kinda moved on and everything, but I had no idea that they wrote it first. Anyway, sorry, I probably didn't need to say that again, but carry on.
well, it's funny that you say they say it backward or they wrote it backwards. So backwards for you, but they were
Oh,
trying to say
right.
it backwards to them. So
Yes,
which is a
yes.
huge indicator that what we're saying, the way that we're describing it, like you were talking about the same values. You
Mm,
were
mhm,
talking
mhm.
about a number of parts and how many parts of the parts. This is a very part whole way of thinking about a fraction. You're saying 4/1/5, right? Because you're talking about the candy bar. But they were thinking about 5 parts. I have 4.
Yeah, yeah,
So that's interesting to me because they're thinking about the whole amount and then what is my share? Like that
yeah,
what they're
yeah.
thinking what's the total first. But when we say 3/5 or 4/5 or whatever fraction you used, we start by saying 4, which if you stop me at that point, I'm thinking 4 whole. Like
Mm,
4 and then
mhm.
I say, "Oh wait, it's a portion of a whole." 4/5 or 4/1/5. It's almost like they already have
4 out of 5.
yeah, they already have that it's a part of something or
From the
it's like the
get-go.
whole yeah,
Yeah, yeah.
it's
Yeah, and you could
interesting.
argue if you know you're thinking about fractions and someone says 4, that you might not go to 4 whole, but you do kind of think about 4 pieces.
Right,
In that way,
right.
that it's the unit, and
Uh-huh.
then you have to picture the whole candy bar, it cut
Yeah.
up into, right?
Uh-huh.
Yeah, it's and so neither is right or wrong. What I
Right.
think the thing that I'm so fascinated about is how the social way that each language, each culture has determined that they are going to what's the word when you say that the socially we've determined something we by
By
convention.
convention.
By convention, they've decided that that we are gonna name the numerator first, and so therefore sort of thinking about the number of pieces that we've got first out of then the total number of pieces that we've cut the hole into, versus they're going to think about how many they've cut the hole into. They're really focusing on the whole and how many pieces they've equally divided into, and then how many of them they need. That social convention is impacting the logical mathematical way that you're making sense of fractions. That's noteworthy. How many times, Kim, have we run into somebody that they'll say, well, that's the way it is. That's the math. And you're like,
Yeah.
I mean, how are you thinking about it? Like,
Uh-huh.
the convention is influencing the way you're thinking about it. And even though those kids very quickly were like, 5/4, I mean 4/5, they're thinking, I've got 5 pieces cut out of the whole, and I need 4 of them. They're thinking that, and then they're translating it into English to say it the right way in English. They're
Yeah.
not thinking about it, at least if they're saying it that way, they're not thinking about it the way we are.
It's
That's
so
interesting. Yeah.
it's so funny that you say that, the right way we say in English, because you and
Did I say
I,
right? Did I say the right
well,
way?
you
I didn't
say,
mean
maybe you
yeah.
didn't. Maybe you said the way that we say in English. The funny thing, but that's making me think, because growing up, I would have said 3/4. Like that was the way to say it. But
Mhm,
you and I
mhm.
also say 3/4.
Yeah. Now
And
we do.
people kind of go, say what? And kind of like raise an eyebrow sometimes. And it's not that we say one over the other. We say them both. We say both 3/4 and 3/1,
Mhm.
because 3/1 is a way to help students understand that 3/4 means 3 1/4 pieces.
Like a
So
fourth and a
that
fourth and a
it's like,
fourth.
yeah, it's like
Yeah.
that nudge is helpful.
Yeah, yeah. So then I took a deep dive. I took a shallow dive and into Google, and I just kind of I thought, well, what about quarters? Like, what about other languages? Are there
Yeah.
other languages? And for whatever reason, I chose the fraction 3/4. And
Hmm.
so I just said, hey, what are other languages doing with 3/4? And I was fascinated to find that a lot of languages will say 3/4 parts or 3/1/4. So like 3/4 in English or tres cuatros in Spanish. Forgive my accent there. Hindi has a way to kind of say, a lot of languages say that. And then I realized, Kim, I wonder if quarters was actually not a good denominator to look up. And sure enough, it's like specific for quarters. A lot of languages have a word like we do. So like we have 3/4, right? 1/4. 3/1/4. But we also have this quarters thing. A lot of
Hmm.
languages has this quarters thing. Fifths. Do we have a word for fifths besides fifths? Not so much. So then I looked up fifths. Oh, then it all switches. For fifths, there's really only a couple of languages that then say, and noteworthy, Korean, Chinese say 5 parts 3. So for 3/5, the way they say 3/5 is 5 parts 3. That I've got 5. The whole is cut into 5 parts. I need 3 of them. Japanese says 3 of 5 parts. Everybody else is more like a part whole, 3 out of 5 parts or 3/5. That's interesting that both Korea and Chinese have this, or Korea and China, can I say that? Korea and China, or Korean and Chinese, have this kind of different way of saying it, but everybody else kind of has this part whole way of saying fractions, and Korean and Chinese have this whole part way of saying fractions, but
Yeah.
almost nobody has the helpful way of saying 4/1/5 or 3/1/5.
Yeah.
But we can pull that in to help with the meaning.
I like how you just said that it's like part whole, but Korean and Chinese say whole part.
Yeah, yeah.
Because they're both attacking that particular meaning of fractions, that part
Of
whole
rational numbers.
relationship,
Yeah,
but
yeah.
in a slightly different way. But what's also really interesting is that what's changing is just the social part of it,
Hmm.
and we're still talking about the same mathematics. And so, like we say 3/1/4. This also happens when we talk about decimals. Like people get really like maybe a little concerned that we say all the different, we say point, we say money versions, we say tenths and hundredths,
Hmm.
because they're real, right? That's like real life. We say 3.2 billion. Um,
No one says 3 2/10 billion. Like no one
no,
says that.
yeah, yeah.
Yeah, and so people
So
sometimes will harp on us like, "You shouldn't say 3.2," and we're like, "Well, how are you gonna talk about our national debt, really?"
yeah.
So, yeah, like, we like to say all 3 of them so that I'm sorry, I'm finishing your sentence.
No, it's okay. I was just gonna say we say all those because it's real life, and because kids are gonna encounter that. And we want to help create a situation where the social part of it, the language part of it, not only doesn't get in the way, but it supports their understanding. So
Oh,
it's
nicely said. Yeah,
yeah,
I like how you said that. Yeah, so social and logical, understanding the different, kinds of, what am I trying to say? Different kinds of, ways of
Conventions.
knowing things, or the different kinds of knowing. That it's important. It is helpful to parse those out. And in this case, wow, it was just like screaming at me, and I had such a good time. And thanks for letting me tell you about that really cool story.
Problem.
Yeah.
Excellent.
All right, y'all. Thank you for tuning in and teaching more and more real math. To find out more about the Math is Figureoutable movement, visit mathisfigureoutable.com. Let's keep spreading the word that math is figureoutable. That's a wrap for today. Want to keep going?
The Math is Figureoutable Challenge is open right now, happening May 13th through 15th.
Y'all, we are focusing on fractions in ways that actually make sense and get success.
Go to mathisfigureoutable.com/challenge to save your spot.
Y'all, that's mathisfigureoutable.com/challenge. We will see you there. Thanks for making math figureoutable.